Okay, so what we're looking at in this video is looking at trying to smooth out or eliminate the effect of seasonal data. And you often hear on the newspaper talking about unemployment figures being seasonal or things like that. So we try to de-seasonalize the data, so we take out the extremes. Okay. All right. So copy that. So when a seasonal pattern exists, it's important to eliminate the seasonal effect in order to examine the long-term trends. Okay, copy that, come across. Okay, so the estimates of the seasonal effects are called seasonal indices, and the process of eliminating these effects is called de-seasonalizing. So that's an E there. Hang on, get a pen. So de-seasonalizing the data. And an example of this, as I just said before, is reporting of unemployment levels, and they use the expression seasonally adjusted figures. Okay, so they're taking out the seasonal effect by adjusting the data. So copy that and come across, and we'll be looking at an example. Okay, so the simplest method of adjustment is called the average percentage method. Okay, so it isn't too hard. So what we've got is some data from different days, and we're looking at the number of lunches sold at the canteen over the past 5 years. Okay, so it doesn't matter if the data's not real. So yeah. So the first thing we're going to do is we're going to calculate the average per term for 2013, 14, 15, 16. So you've got 4 sets of numbers. So just add them up and divide by 4. So I want you to pause the tape, and when you're ready, come back. Okay, so let's have a look at our numbers. So these are 22,950. These are approximate. Like, you don't have to give to the exact number. 475, 22,325. And 23,975. So I think they're numbers. Okay. So now what we're going to do is we're going to compute the ratio of this number, all these numbers, to that number there. Okay. So we're going to be dividing in the year the term number by the average. So we're going to end up with decimals. Okay. But we're going to do it 16 times. So I want you to, again, I'll just do the first one. So the first one here would be 20,600 divided by 22,950, and that equals approximately 8976. So I want you to pause the tape and give me the rest of the numbers, because we need those. Okay, next, it doesn't matter which way you go. 1.0458. 1.1416. These are my numbers. I'm hoping that the same as yours. 0.8870, 1.0669, 1.1339, 0.9121, 0.9499, 1.0477, 1.0710, 0.9313, 0.9138, 0.9989, 0.1198, 0.9675, one to go, 0.9468, 1.0886, 1.0594, 0.9051. And what we're going to do now is we're just going to average those numbers going down to get like a term average. Okay, so this will be like a quarterly index or a term index. Okay, so you can see most of the lunches are sold in term 2 and 3. Term 1's the lightest term, but I want you to get the 4 averages and come back when you're ready. Okay, 9190, 1.0496, 1.1051, 0.9262. Okay, so we're going to use those numbers to make an adjustment by dividing the actual figures. So we're going to go back and we're going to divide those figures by the relevant seasonal adjustment. Okay, so copy that and come across. Okay, so the seasonally adjusted figures can now be found by dividing the actual numbers, the real data, by the seasonal index, and then this data can be analysed for long-term trends. Okay, come across when you're ready, copy that. Okay, so we've got the original data, we had those numbers there, so we're not going to do every single bit of data, but we'll just do the first one. So we're going to take term 1, hang on. So I was just looking, so that number's 20,000. So we're going to take the 20,600 and we're going to divide it by the average, which is 91, and so this number will change to 22415, and then as we go down, each of these numbers also changes in there. Okay, so we could do it for the other terms, and then once you've got the seasonal adjustments, we can then look at different trends. Okay, so I haven't done the other ones, but if I was going to do it, it would be sort of 24,000 divided by 1.0490. I have a calculator with me, so hang on. Calculator equals 24,000 divided by 1.0498. 96. 24,000 divided by 1.0496, and so it's 22,866. Okay, so I'm not going to worry about getting the rest of the data. It's just mechanical, but there'll be an exercise to do on Maths Quest, and that's all we need to do. Okay, practice. See ya.